Hello and welcome to my channel. So today we are going to be looking at some questions on exponential equation. How we can solve questions on exponential equation. Now let's look at these questions one after the other. So the first question, 1 over 3 raised to power x equals 27. Yes, before I say anything or before I proceed, I want us to understand something. Solving questions on exponential equations of this type has to do with some things you should take note of. That when solving questions on exponential equation, the general rule is the base must be must have either a positive or a negative unknown equals to a number that which when you take it to its lowest common base, it's going to be the same with the base you have on your left hand side. Let me take this again. When solving questions on exponential function, exponential function, exponential equation, let's note that the left hand side should or will have a base and an unknown that we want to solve. And this unknown may be positive or negative. That is the power that we want to solve. It may come in positive form or negative form, and of which this one is in positive form, and it may come in negative form. So this is how it should be. However, if it is not in this kind of category, then it is our job to make sure we transform the questions to be in this kind of category. That is just it. So, looking at this first question, we can see a fraction. It doesn't fit in any of these. Our job is to make sure it fits in any of these. Then, the number two question, we can see it doesn't really fit in. Number three questions, and so on and so forth. So we are going to know how we iron them out in such a way that they look like this. So now look at this question. This is 1 over 3 all raised to power x. In order for it to look like what I've written, let me write it somewhere. And let us note something, that because the letters, that is the unknown we look for, always fall on our left hand side. That is, the rule of algebra is the unknown, either x, it may be y, it may be z rather. When you are looking out for them, or when you are trying to solve questions relating to finding the unknown, it is always by or on your left hand side. However, you may see questions that of which the unknown may be on your right hand side. But at the end of the day, you what? You will still have no choice than to what? Than to take it to your left hand side. That is why when you see questions, you will always see that the unknowns are always on our left hand side. Now, looking at this question, 1 over 3 all raised to power x. It is not in its right format. Our job is to make sure it is in its right format. Then, how do we proceed with this? Let's not forget that in our laws of indices, there is a law that states that 1 over x is the same thing as saying x raised to power minus 1. If 1 over x equals x raised to power minus 1, then x raised to power minus 1 is also equal to 1 over x. They go together, pari passu. That is, if 1 over x equals x raised to power minus 1, then x raised to power minus 1 can also be regarded or can be equal to 1 over x. So, we are going to make use of, so now we want to make sure it is in this format. Then the way we are to do it is, we now say 1 over 3 can be regarded as 3 raised to power minus 1. And let's not forget that there is x outside before, equals 27. Aha. Now it is beginning to look like one of these formats. Then let's not forget that when you find two powers on the same page, that is on the same level, you can always multiply out. So I can say this is 3 raised to power minus x equals 27. Aha. So we have ended up solving a question that now looks like a typical exponential question that is having unknown. So our next job is to make sure that our right hand side, we should take it to a base that is equal to our left hand side, so that when we raise that number or that base, we are going to raise it to a certain number that when you multiply them out, it gives us 27. So what is that number? It's 3 raised to power minus x equals 3 raised to power 3. So I know that when I multiply 3 times, it's going to give me what? 27. And I've explained in the other videos on how we can always try and get the numbers, and when you multiply it gives us a certain number using prime factorization method. So we have, now that we have equal base here, we now equate powers, and we have minus x equals 3. Let's not forget that we are asked to find the value of x and not minus x. So what do? We are going to find means of what? Of taking this negative sign away from it for it to be positive, because the question is asking us to find x, not minus x. So what are we going to do? We multiply both sides by a negative sign, so that minus times minus will give me what? Positive x equals minus 3. And minus 3 is our answer. So let's move on to the next question. We have 2 raised to power x equals to 8. 2 into bracket 2 raised to power x equals to 8. Now, this is the same as saying that x raised to power a times x raised to power b equals x raised to power a plus b from the laws of indices. As you can see, it's the same as saying 2 raised to power 1. You know, this is having an invisible one, because 2 raised to power 1 will give us 2, times 2 raised to power x, which is equal to what? 2 raised to power 1 plus x. Let's not forget that if I were to represent it with what I have here, then it means it's going to be 2 raised to power 1, 2 raised to power x. And I can as well say this is x raised to power a, x raised to power b, which is equal to x raised to power a plus b, which is the same as 2 raised to power 1 plus x. So from here, how do we go about this? So since it has been illustrated above, so I can as well say 2 into bracket 2 raised to power x equals 8 is the same thing as saying 2 raised to power 1 plus x equals 8. From the laws of indices, I derive this, that if this is 2 raised to power 1 times, this bracket here means times 2 raised to power x, then using laws of indices, that x raised to power a times x raised to power b equals x raised to power a plus b, I can as well say this is 2 raised to power 1 plus x equals 8, because the law of indices has taken place here. Then now, like I said earlier, that the left hand side is where the unknown usually lie. That's where it lies, that's where it stays. So, and on our right hand side is the other side. But in this case, our unknown is always cited on our left hand side due to the fact that the unknown, as in the rule of algebra, the unknown, which is either x, y, or z, should be on our left hand side. So from here we have 2 raised to power 1 plus x equals 8. And if I were to take it to my lowest common base, looking at what is on my left hand side, then I have to make my right hand side to be like my left hand side. Meaning that if I can see 2 on my left hand side, then it means I can break this down to 2 raised to power something. That's what it means. So we have 2 raised to power 1 plus x equals 2 raised to power 3. Then the bases are equal, then you what? You equate powers. You equate powers. And if I want to equate powers, it becomes 1 plus x equals 3. 1 plus x equals 3. The question says find x. So how do we do it? This is 1 and this is x. So which means x should be on its own and letters should be on its own while numbers should be on its own. So in order for that to happen, let's not forget that the sign of every number or letters is always at the left hand side, or it's always by the left hand side of everything. So the sign of x is positive, that is what you can see at the left hand side, and the sign of 1 is also positive. It is invisible, you cannot see it, but it's the left hand side. Any number, any natural number, or can I put it like this, any whole number like this, they all carry invisible positive sign unless it is stated that it is negative. That is when we know that it is not positive. So how do we go about this? So we need to isolate x. We need to let x stand alone. So what is disturbing x at the moment? This number. So what do we need to do? We need to send this number packing. We need to chase this number away from this area so that it will meet its fellow brother on the other side. So what do we have? When I chase 1 out, x remains. Then this 1, it's carrying it's a positive sign. Anytime it passes through this equality sign, it changes to negative. Take note, any sign you have here, once it passes through the equality sign, the sign will always change. What if we have -1 here? Once it passes through the equality sign, it will change to positive. If we have +1 here, once it passes through the equality sign, it changes to negative. So from here, I can say x equals to 2, and that is my answer. Let's move on to number 3. 0.25 raised to power x plus 2 equals 64. 0.25 all raised to power x plus 2 equals 64. Let's not forget that the nature of the question shouldn't be in this format. It should be in something like this. A format of this nature, that's what I mean. I don't mean it has to be 3 raised to power x, but it should be a format of this nature. Now we have decimal. Unlike our number 1 question, when it was fraction, we had to change it to look like one of these. Now we are also going to do the same for number 3 question. Now if you look at this question, it's starting with a decimal. What do we mean by this? The first thing we are going to do is we change our decimal to fraction. Anytime you come across questions like this, please, the first thing you should do is to change this decimal to fraction. So I can say 0.25 is something as saying this is 1, and every other digit that come after it, you write 0 and you write 0. So this is like saying 25 over 100. So let's get back to work. So we have 25 over 100 all raised to power x plus 2 equals 64. So from here, we are going to divide to its lowest term. The reason why it is like that, I will let you know later in this video. So 25 here, 1, here is 4. So it's just like saying 1 over 4 all into x plus 2 equals 64. Now, going by this, let's not forget that this nature, this format, it is not in its right format. Our format should be a base on our left hand side carrying either a positive unknown or a negative unknown equals to another number on our right hand side. That is the nature of an exponential question. So in this case now, we have to make it to be in this format, one of this format. And by the way, take note, anytime you see a negative power, or sorry, a negative power which happens to be an unknown power, it means the origin is from a fraction. Take note, it means that its origin is from a fractional number. So in this case, 1 over x is simply as saying x raised to power minus 1. However, x raised to power minus 1 is also the same thing as saying 1 over x in one of the laws of indices. So on this note, I can as well say that this 1 over 4 is simple as saying 4 raised to power minus 1 all into bracket x plus 2 equals 64. Aha. Now, from here, I can see that my left hand side is having a base 4. Then our job is to make sure our right hand side is having a common base just like my left hand side. It means that on our right hand side, we need to take 64 to be 4 raised to power something, and of which when I multiply that 4 by that number, by the number of times, it will give me what? 64. So what do we have here? So from here I can say this is 4 raised to power minus 1 all into bracket x, this plus 2 equals to 4 raised to power 3. So 4 raised to power 3 is, that is, if I multiply 4 3 times, it gives me 64. 4 times 4 is 16, and 16 times 4 is 64. So why did we divide to its lowest term? We divided to its lowest term because I know that 64, which is on my right hand side, that at the end of the day, when I divide to its lowest term, there's a way it's going to be in such a way that the lowest common base will be 4. Let me take that again. The reason why I divided it to its lowest term is because of my right hand side. My right hand side is 64, and I know that at the end of the day, because of the 4 that I've seen here, it means I can automatically take this 64 to be 4 raised to power something, of which it will give me 64. However, please take note of something. It is because I know that I can take 4 to a certain number, to a certain power, and of which it will give me 64. That is why it is like this. If the number on my left hand side, or let me put it like this, if I notice that the number on my right hand side, and if I notice that if I use 4 as my base and I raise it to a power and the answer does not give me 64, automatically it means that what I need to reduce this 4 to the lowest. I can say this is the lower common base. I can take this to its lowest common base by reducing this 4 to 2 raised to power. This 4 can be reduced to 2 raised to power 2, and I can also reduce this 64 to 2 raised to power, you understand, 2 raised to power 6. Now, but because I know that if I should take 4 raised to power something, I will definitely get 64, then there's no problem. I can leave it like this. Because if you reduce it to 2 raised to power, it's just like you are increasing the load again in solving. So from here, I can as well say that this is 4 raised to power minus 1 into bracket x plus 2 equals 4 raised to power 3. So we have 4 raised to power, I'll open my bracket, minus 1 times x will give me minus x, minus times plus is minus, 1 times 2 is 2, equals 4 raised to power 3. Can you see? Look at it. Minus 1 times x is minus x. Minus times plus, please, anytime you see a negative sign outside, please make sure you multiply with the positive sign inside. Minus 1 and minus times plus is minus, 1 times 2 is 2. So now you can see that the bases are equal. So we now say equate powers. So we have minus x minus 2 equals 3. Then we are making x stand alone, so we have minus x equals, now as you can see, this is minus 2, and we want it to join this 3 here. I want minus x to stay alone. So we have this 3 has been here before, so this Mr. 2 is going to join 3, and however, you can see minus 2. So once it passes through the equality sign, it changes to plus 2. So we have minus x equals 5. However, the question is asking us to find the value of x, not minus x. So what do? We multiply both sides by a negative sign. Why do multiply both sides by a negative sign? Because I know that if I should multiply minus times minus, it will give me a positive sign. And let's not forget that the question says find the value of what? X, not minus x. So minus times minus is plus, so it's going to be x equals minus 5. And that is my answer. So let's move on to number 4. Two raised to power x equals 1 over 8. Please don't forget to subscribe to my YouTube channel. Like, comment, and share. Thank you. So how do we solve this number 4? 2 raised to power x equals 1 over 8. I can as well say this is 2 raised to power x equals 8. 1 over 8 can be the same, is the same thing as saying 8 raised to power minus 1. Let's not forget that 1 over x is the same thing as saying x raised to power minus 1. So on this note, I can say this is 2 raised to power x equals to, my left hand side is having a common a base of 2. So automatically it is kind of giving me a signal that on my right hand side I need to find a common base like the left hand side, and that is what? 2 raised to power something. Now when I multiply it, it's going to give me 8. And what is that number? 3. So it tells me that 2 raised to power 3, if I should multiply 2 3 times, it gives me 8. And you can as well use that. You can as well use prime factorization method. This is what I mean by that. 2, I know that 2 is the lowest number that can divide, though I know 1 can divide. In fact, 1 is a universal number. It can divide all numbers. But in this case, we have to start from 2 here. So 2 in 8 is 4. 2 in 4, 2. And 2 into 1. So I can see that when I multiply these two 3 times, 2 raised to power 3 will give me 8. So let's proceed. So we have 2 raised to power x equals, no, this is a power and this is a power, another power. They are together. It's just like saying x raised to power a times b. In this case, in the law of indices, a times b is going to be x raised to power a times b, which is simply saying x raised to power ab. So when you find two powers on the same level, you multiply out and write your answer there. So on this note, I can as well say that 2 raised to power 3 all into bracket minus 1 means that this 3 and this minus 1 can multiply themselves. So it's going to be 3 raised to power 2 raised to power 3 times minus 1, and that is what? Minus 3. So now the bases are the same, so we equate powers, and we have x equals minus 3 automatically. There's no need for us to say multiply both sides by minus. No, since this x is already positive, and there's nothing we can do. It's okay like that. We can leave our answer like that. So we'll move on to the 5th question and the final question. The 5th question is 10 raised to power minus x equals 0.00001. How do we solve this? So the first thing we need to do, anytime you see a decimal number, please don't forget, take it to fraction. Take it to fraction. And if you see that if there is need for you to divide to its lowest 10, do so. If there is no need for you to divide to its lowest 10, you can leave it like that and continue your work. So we have 10 raised to power minus x equals to, automatically this is saying this is 1. And how many digits can we find here? 1, 2, 3, 4, 5. So we'll just write 1, 5 zeros, 2, 3, 4, 5. So it's same thing as saying 10 raised to power minus x equals 1 over 100,000. So 10 raised to power minus x is equal to 1 over 10 raised to power 5. If you look at the difference between question 4 and question 5, you can see here 1 over 8. I started by saying 8 raised to power minus 1. However, if you like, you can take this to its lowest common base by writing 2 raised to power 3, just like the way I did for this. I can as well say 2 raised to power x equals 1 over 2 raised to power 3, and at the same time, I can swipe it back, of which it will still give me 2 raised to power minus 3. If anyone that pleases you, you can do it. So we have 10 raised to power minus x equals 10 raised to power minus 5, because I know that 1 over x raised to power a is equal to x raised to power minus a. Take note. So the base are equal. I'll just equate powers. And what do I have here? I have minus x equals minus 5. Definitely the question is asking us to find x, not minus x. What do? We multiply both sides by minus. So minus times minus is plus, as x equals minus times minus is plus. So x equals 5 is our answer. Thank you very much. Hope you enjoyed this video. Please don't forget to like, share, and subscribe to my YouTube channel. God bless you as you do so. Thank you.